Hello dear students, let's start new chapter States of Matter, Gases and Liquids. As you all know, first see what are the topic reduced in this chapter. Whole you have to study except this characteristics of gases, comparison between solid, liquid and gases, properties of gases on the basis of kinetic theory of gases, postulates of kinetic theory, concept of average, root mean square and most probable velocities, non-ideal behavior of gases, liquid state, vapor pressure, viscosity and surface tension. These topics have been reduced for this year. So let's start the states of matter. Do remember children that liquid has been deducted. Gases mostly we have to study and solid we will study, you all will study in class 12th. Matter, what is matter? Matter is defined as anything that has mass and occupies space. As you all know that it exists in three physical states with solid, liquid and gas. And any substance can exist in either of the three states depending on the temperature and pressure. Gases can be converted into liquid and liquid can be converted into solid. How? And all are interchangeable. When we will compress gas, it will become liquid, means when we are increasing the pressure, gas is becoming liquid, and when again we are increasing, it is becoming solid, and vice versa. So you can see that solid changes into liquids and liquid changes into gases under appropriate conditions of temperature and pressure. And this phase transformation is accompanied by either absorption or evolution of heat energy. Means energy is either absorbed or evolved during any of the changes in the phase. Thus, a substance possesses least energy in the solid state and maximum energy in gaseous state. Okay, do remember that a substance possesses least energy in the solid state and maximum energy in the gaseous state. And most of the observable properties of chemical world are the bulk properties of matter. That is, it is not the property of individual constituent units, viz. Atom, molecule or ion. Water is liquid in ordinary temperature and pressure and it can be changed to steam, that is gaseous phase, by heating at 100 degree centigrade, whereas it can be converted into ice, that is solid phase, below 0 degree centigrade. And you have to remember that at 1 atmospheric pressure, liquid and solid states of matter are regarded as condensed states because they have much higher densities than gaseous state. So we can see that liquid state is the intermediate state between the gaseous state and solid state. Gaseous state is your completely random state and solid state is orderly management of molecules. So liquid state is the intermediate state between gaseous state and solid state. Let's see what is intermolecular forces. Forces of attraction between the molecules of a substance. Substances are what? Gaseous, liquid or solid is called intermolecular forces. Liquid and solid states of matter are regarded as condensed states. If a sample of gas is cooled and compressed sufficiently, the molecules approach each other and intermolecular forces of attraction come into play. And at this point, condensation or liquefaction occurs. On further cooling, short range intermolecular forces become more strong and liquid undergoes solidification. Intramolecular, that is, bonding forces stabilize individual molecules. That is, hold atoms together in a molecule by ionic, covalent, or metallic bonding. Whereas intermolecular forces are primarily responsible for the bulk properties of matter, such as melting point, its boiling point. That is, these forces act between various molecules of a substance. Generally, intermolecular forces are much weaker than intramolecular forces. Okay, intermolecular forces are much weaker than intramolecular forces, and it is observed that much less energy is required to evaporate a liquid than to break the bonds in the molecule of a liquid. And the boiling and the melting points of these substances often reflect the strength of the intermolecular forces operating among the molecules. Higher boiling points or melting points speak about higher values of intermolecular forces. Means if any compound is having higher melting point or higher boiling point, you have to understand there that its intermolecular forces is very high. And these forces are not only present in polar molecules but also in non-polar molecules. And this was first pointed out by the Dutch scientist Johannes van der Waals. And these forces are also termed as van der Waals forces. Van der Waals forces includes different types of intermolecular forces such as dipole-dipole forces, dipole-induced dipole forces, dispersion forces. And it is important to note down that ion dipole interaction is not included among the van der Waals forces. Moreover, the hydrogen bonding is a very strong type of dipole-dipole interaction which is formed by few elements. Thus, ion dipole interaction and hydrogen bonding has been kept separately. Let's see what is dipole-dipole forces. Compounds having atoms of different electronegativities act as a dipolar. Okay, and the molecules like sulfur dioxide, nitrogen dioxide, HCl, etc. are polar molecules. Dipole-dipole forces are forces of attraction which act between polar molecules. You have to remember that dipole interaction occurs between the polar molecules. That is, between the molecules that possess permanent dipole moments. When polar molecules lie near one another, as in liquid or solid, their partial charges act as tiny electric field that orient them and give rise to dipole-dipole forces. The positive pole of one molecule attracts the negative pole of the other. Here you can see that the HCl is a polar molecule. Chlorine is more electronegative. And when this will kept together, in solid they will have a definite shape and structure. So all this plus negative plus minus means positive negative will be attracted towards each other. And in liquid also, if molecules are at different positions but they're positive, negative, negative, positive, negative, positive. So the arrangement is more orderly in the solid phase of a substance than in a liquid phase. And this dipole-dipole interaction is also called Ch5 force. Why? Because of the name of the scientist. This was first studied by Ch5 in 1912. Let's see what is dipole-induced dipole forces. The force of attraction exists not only between molecules with permanent dipole but also between the molecules of a permanent dipole and the non-polar molecules. Okay, if an ion or a polar molecule is placed near an atom or a non-polar molecule. See this figure, water is your polar molecule and xenon is your non-polar molecule. The electron distribution of the atom or molecule is distorted by the force exerted by the ion or the polar molecule. Whatever though it is non-polar but it contains electrons. Okay, so what will happen? The polarity will be induced in the non-polar molecule. The resulting dipole in the atom or molecule is said to be induced. You have studied this, all these induction, mutual attraction and this type of forces in physics. So it is induced, means your xenon molecule was non-polar. Water is polar. When both the molecules are kept together, water has induced polarity in the xenon molecule. And because the separation of positive and negative charges in the atom or molecule is due to the proximity of the ion or a polar molecule. Because of this polar molecule, because of this water only, this xenon is showing the polarity. And the attractive interaction between an ion and the induced dipole is called ion-induced dipole interaction. And the attractive interaction between the polar molecule and the induced dipole is called dipole-induced dipole interaction. Okay, and the ease with which an atom's or non-polar molecule's electron cloud can be distorted is called its polarizability. With this template also you can understand. Permanent dipole, a polar molecule. Polar molecule, when it is kept near the non-polar molecule, it is inducing and it is making also polar. Okay. Next is dispersion forces. This is also known as London dispersion forces. And what is London here? The name of the scientist, not the place London. Okay, so intermolecular forces exist even in non-polar molecules. Benzene, for example, has zero dipole moment and therefore experiences no dipole-dipole forces. Nevertheless, there must be some intermolecular forces present among benzene molecules because the substance is a liquid rather than a gas at room temperature with a melting point 5.5 degrees centigrade and the boiling point is 80 degrees centigrade. So all particles, whether individual atoms, ions or molecules, experience London dispersion forces which result from the motion of electrons around atoms. The origin of these forces was studied by Fritz London in 1930. In order to understand the origin of these forces, take the example of two noble gas atoms very close to each other. Each atom is uncharged because its electron cloud is symmetrically distributed around the nucleus. However, at any instant, the electron cloud in an atom may be unsymmetrical, giving the atom a short lived dipole moment. And this instantaneous dipole on one atom can affect the electron cloud in the neighboring atoms and induce temporary dipoles in the neighbors. As a result, weak attractive force develop. This you can see in the diagram. London forces are generally small. Their energies are in the range of 1 to 10 kilojoule per molecule. However, the exact magnitude depends upon two factors. The number one, molecular mass and molecular size, and number two, molecular geometry. Next is ion dipole interaction. This I will take in my next lecture. Okay, so as this is the start of this chapter, so I will not rush. Small chapter it is, so little small topics we will discuss so that it should be understood by you all. So thank you, children.